Whether you consider June 1st the beginning of summer, as many meteorologists do, or the summer solstice, which is this Sunday, as astronomers do, we always use June to welcome back our resident astronomer, Dr. Chris Palma, from the Penn State Department of Astronomy and Astrophysics. Always good to see you, Chris. So, I'm a huge fan of sending unmanned probes to study other planets. And I just saw that NASA announced it had lost contact with a probe that's currently orbiting Mars. It seems like this probe, which is called Maven, lasted a lot longer than it was supposed to. What's the story there?
Yeah. I mean, typically these probes last, like if they make it through the first year, they often will last a long time, right? So they often have a nominal mission time. Like, we need to have this last at least 2 years to achieve the primary goals. But hey, if it keeps going, let's keep collecting data. And so Maven made it 12 years. But I remember I learned space is hard. So many things can go wrong. And so it does seem like something has gone wrong. The spacecraft is spinning now, and so it can no longer point its antenna back to Earth, and we just can't communicate with it any longer.
All right, so these things have to be properly oriented in order to send signals back to Earth.
Yep.
Speaking of Mars, NASA is still talking about sending humans there, but the first step would be to get back to the moon.
Yes.
And I saw last week that NASA announced who the astronauts will be for the Artemis III mission. Artemis II just completed. How is Artemis III different than Artemis II, and how does it fit into the big picture?
Yeah. So the difference is we're doing this in stages, right? Like, we need to very carefully, can this rocket send a ship to the moon and back? Are we going to be able to, when we get there, have a landing craft land on the moon? And so what this mission is going to do is it's sending the astronauts to low Earth orbit. So they're going to stay closer to Earth, but it's really going to practice all the maneuvers they have to do and test all the technology to dock their ship to a lunar lander. And so that's the next step before we actually are able to land on the moon. So it's going to be another exciting mission.
It's interesting. So Artemis II actually went to the moon, but Artemis III, they step back and they just work on these things in Earth orbit.
Yes.
Two stories from your department caught my eye, in part because both of them involve one of your newer faculty members. They're both about planets outside of our solar system, and both of them use this James Webb Space Telescope. But they seem like different approaches. Can you fill us in?
Yeah. This is really exciting to me as well, and it really does show something we've been talking about probably for 10 years now, right? So we talk about these missions like Maven that go to Mars and study Mars, and then on the other hand, us as astronomers, we use telescopes to observe very, very distant planets that are 100 or 500 light years away. But we're getting to the point where we can take what we're learning about Mars and Venus and Jupiter and start applying that to these very distant planets. And so what the James Webb Space Telescope was able to do was actually able to detect light reflected off of the planets directly. So it's not it's starlight, but it's starlight that hit the surface. And so we determined that these two planets, one is very much like Mercury. It's a bald rock with no atmosphere. Just everything we got from that is just clearly solid rock reflecting light. Whereas this other planet is like Saturn, and we got evidence that there's methane in the atmosphere of this very, very distant point of light. So that's what James Webb is finally allowing us to do, is study distant planets as if they were in our own solar system.
Yeah, that's truly remarkable. So you're literally using the starlight from the stars that these planets are orbiting.
Yep.
And detecting that light. That's seems to me a real big step in studying these exoplanets.
Absolutely.
And speaking of space telescopes, the Hubble telescope seems like it's been around forever, something like 35 years, which means that now you can start comparing what it saw 30 years ago with what it's seeing now, and literally watching celestial objects change. And you mentioned one that had caught your eye.
Yeah. I mean, the reason it caught my eye, it's called the Crab Nebula, and it is one of those objects that our department, some of the folks that I've worked with over the years, studied intensively. And so this is the remnants of a star that exploded 1,000 years ago. There's actually historical records of people seeing the explosion in the year 1054. Now there's this cloud that is expanding away from that explosion at 300,000 miles per hour, right? So incredible speeds. And over the lifetime of the Hubble Space Telescope, you can actually see the cloud expand. So normally us as astronomers, we tell people, oh, this is going to take 1 million years to happen, so no one's going to actually see it in their lifetime. This is a case where we saw the cloud change because we've been able to study it for 30 years.
And this is a really nice example that also applies in my field. This is why you need long periods of record.
Yeah.
From whether they be telescopes or instruments to capture these changes.
Yeah.
Yeah, that's really cool. So we always finish by asking you to tell us, what will you be looking at in the night sky in coming weeks?
Yeah. So if any of you have been outside recently, we've had a string of really nice weather. You can see at sunset 2 really bright points of light, and that's Jupiter and Saturn. They absolutely catch your eye because they're so bright. And what's happening is Venus, I'm sorry, I said Jupiter and Saturn. I meant Jupiter and Venus. Venus is moving around the sun faster. So these days they're like this, but as time goes on, Venus is going to move further and further away. So I want people to watch those separate as time goes on.
Okay, very cool. Yeah, these I've seen them in recent nights in the night sky. Dr. Chris Palma, Penn State Department of Astronomy and Astrophysics. Always great to see you, Chris.
Thank you.
And we will be back in a moment with more.